Hello guys, and welcome back to Classic Arcade Repairs. Today in this repair video we have a, can you guess? Well, you'd probably see by the title. Anyway, it's a Crystal Castles. Yeah, at the time that I'm recording this I don't really think about, well, I'm going to have the name of the game in the title, you know, so I just pulled this out of the box. And here it is. This is pretty cool. I get to deal with a Crystal Castles game. So this one, there's some notes on it here that says what it said is that there's no video. There's like 2 tones or something like that in test. So apparently it's going through test, but there's no video. So let me go ahead and get my harness out and get everything all hooked up and ready to go, and we'll see what this thing does. Okie dokie, Crystal Castles. We're all hooked up. I got the harness hooked up to it. Everything's plugged in. I got my G07 monitor plugged in. And let's just go ahead and I'm going to give you the monitor. You can see what's going on the screen. You'll be able to hear the speaker, I think. So let's see if anything goes on with this thing. Alright. And we're gonna, on the count of 3, I'll fire it up. 1, 2, 3. White screen. Okay, you hear what it's doing. It's doing 2 high beeps right off the bat. I'm going to go through and test the power rails. Make sure our voltages are all good. Our voltages are all where they need to be. Ooh, we got 5 on the dot. 5 volts on the dot. Here's our 5 volts unregulated, the 13 or whatever it is. And I really don't think this thing gets an odd voltage. I think 5 volts is all this board gets. It's got to get 12, right? See where. Huh. Okay, I'll look around for a 12 volt lug, but I do not see. You know, I'd figure for sound this thing would have to be getting 12 volts. Right? Anyway, that's what we're getting. Just 2 high tone beeps. And I also have it in regular. I don't have it in test. And it's just doing this over and over. So, okay. I don't think that this is an actual... I think this is an issue other than the 2 tones. I think that my initial thought is that this is a decoding problem. of some sort, and it's just giving it a false failure. That's my guess. This won't even try to run program. It won't even try to run program because it's not in test, and it's beeping at me. So that's what I'm going to look at first. Is I think first thing right off the bat is putting the fluke on this and going through the ROMs and the RAMs. I think that'd be a good place to start. I'll get the scope and I'll look around CPU signals, make sure the CPU signals are all good, but I think they will be. I think this is purely a decoding problem. So let me do all that, and we will be back. All right, right off the bat, one thing I want to do, I want to eliminate, or at least look at. Let me plug this monitor back in. Uh-oh. I need to replace this. This connector's no good. Whoa, man, that thing snaps at me. Okay. I want to remove the two pokey chips and then turn this thing on. Because I know that blown out pokies can interfere with the bus lines. And we will be right back. I gotta run out really quick. Okay, I'm back. That was my son Thomas. I had to run him to work. Like I said, I'm just going to remove these guys. Get them off of the address and data buses. And we'll see what this thing does now. Okay, it's basically the same thing, nothing. It's the exact same looking screen, but no sound. So let's turn it off. I'll just put these guys back in the board. These pokies. And of course we've got these great sockets. Come on. You know, these fantastic sockets. All right. All right. We're going to fluke this thing, but before I do, I have to replace this socket. The fluke will not work with this socket. It just won't do it. Won't happen. And I'm also going to have to remove these because the fluke goes this way. And those are in the way. So I'm going to have to remove these and then re-solder them back in later so that I can put the fluke on it. And I'm confident that this CPU is good because it's doing something. Okay, looks like we got some damage underneath here where somebody removed this CPU, but I don't think that's really causing an issue. But I'll clean that up. And TMS 4416. I need to do a cross-reference on these 4416s and find out 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 18 pin, but that is not a 2114, I don't think. These RAMs, I really need to buy some of these RAMs in. There's a custom. These are RAMs. These RAMs right here, 4416. Okay, yeah. And then you got 2212s right here. Those are RAM. That, I would guess, is probably your non-volatile RAM. Maybe. No, I don't think so. Here's an 82S09 RAM. This thing doesn't have non-volatile RAM, I don't think. 2149 RAMs up here. Crystal Castles. Yeah, I think the first thing I'm going to do is prepare this thing for my fluke. Get this socket out of the board, remove these guys so that I can use my fluke, and go from there. So let me do that, take care of all of this, and we'll be back and ready to roll with the fluke. Okay, I have the new socket in the board and I have these guys removed, and you'll see I did have to kind of repair the reset trace. And these other ones, the only one that really matters is the 02. It comes over here, and that's fine. It's just the reset pulled out, which, whatever. The rest of them are fine. So, new socket. We'll go ahead and hook the harness back up, get everything plugged up and ready to go, and put the fluke on this thing and see what it tells me. I got to go over to the computer and download, or see if I've already got the fluke information for this board. So I'll go ahead and do that. Get the memory map all squared away and ready to go, and we'll figure that out. Okay, I got my memory map out for Crystal Castles, and I've gone through the 3 program ROMs. Just stop that. I've gone through the 3 program ROMs, which this is Crystal Castles 3 in MAME. These 3 guys right here are all perfect. Now what's curious is I got to these 2, and look at these addresses. This is not a 16-bit system. That's an illegal address. You cannot put 10,000 to 11 FFF in here. You go ROM 10,000 to 11 FFF. Illegal address. You know, this is not a 16-bit system. You can't do an address like that. So I'm curious what kind of mirroring is done. Are these 2 even accessible to the CPU? I don't know. Not at that address, it's not. But there might be something funky going on in this system to let the CPU have access to those. And what I want to do once I get this board working 100% is I want to do a learn function with this thing and learn all of its, you know, all the CPU's data. Its RAM, its ROM, its I/O stuff, and all of that. And see exactly what it says. So, but as far as the program's fine. It's given me 3 beeps, so I'm going to assume that it's just 3 beeps. I'm going to, of course, yeah, it's 3 beeps. So I'm going to go ahead and look at the manual and see what 3 beeps means. 3 high beeps. So let's do that and then come back. Okay, so if you remember, we had 3 high tones and the rest of them were low. And that is the third scenario here. High, 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 low, 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 low. And that says RAM at 4H is bad. 4H. So if we come over here, I'll show you what I've done. 4H. I have removed 4H and I have run that very RAM in my Inquisitor, and you can see it is okay. So I believe we have a decoding issue getting to these RAMs. So I'm going to put a socket in here, put this RAM back in the board, and go from there. And we'll have to find our decoding issue. Okay, we are back to powered on. And you'll see I don't even have a RAM chip in it yet. And remember, that was 4H. 4H. 3 high, 4 low. So, let's turn it off and let's put our tested good 4416 RAM in the board. And we'll get the same thing. Same thing. Okay. And we can do RAM short at, I believe it's 0 to BFF, I think. RAM bits 0 and 7 tied. RAM at 3 to BFF. Now it gives me a read-write error at the first. This is 3 to BFF is the actual work RAM, according to this. Zero 3 to BFF is working RAM. Yeah. And it's getting back every bit wrong, every bit bad. If I do a RAM short, shut up. Okay. If I do a RAM at 0 to 3, I get every bit bad at that address, the first address. Okay. Let's do RAM short at 0 to BFF. Read write error. Continue. Huh. Jumping around a little bit, but pretty close. So we have data bit error. We have data error every bit. So I'm gonna actually put the I'm gonna actually run the thing and turn the volume down and run the UUT. And what I want to do is just probe around and find out what's not working that should be working. I need to get the CPU side schematic out and go from there. But if this ends up being in my way, I'm going to have to just remove this, just put the CPU in there and find out what's going on. I can get to the ROM good, but I need to find out why I can't get to the RAM. That's the problem, is I have no RAM access. So, all right, let me get the schematic out, the CPU to the RAM schematic, and go from there. All right, guys. I'm going to use that little guy so that you can see it. And we'll start looking at this board a little bit. I got Crystal Castle's schematics out. Crystal Castle. Put that guy over there, maybe. I gotta move a lot of this stuff. Crystal Castle. A lot of junk here. I actually want the CPU thing first. And of course, I don't have the CPU schematic printed. I've got a lot of stuff here, but I don't have the CPU part. So I'm gonna stop the camera. I will be back. I'm gonna print and put together the CPU schematic. Okie dokie. You know what? I printed. This is the CPU part of Crystal Castle's, and then I got to thinking. I was like, why am I printing? I mean, I'm glad I printed it because I can put it up with my. But I don't need this. I need the decoding stuff. So I'm confident that CPU side of things is just fine. So Crystal Castle's. I'll put this stuff up here. I need decoding address selectors. I mean, that could be an issue right there, address selecting. Potato. This chip is called Potato. That is this thing. And if that is bad, that is an Atari custom right there. Potato. If that thing is bad, we're done. I doubt that that's bad though. Let's just fire this thing up. Let me kind of scoot around. Okay. I got to set this up. Turn the game on. I'm going to kill the volume. I don't want to listen to that nonsense. Okay. Potato. I'm going to plug in the monitor so that I can see the screen. Alright. We have the fluke rolling. We have the fluke on. We have the little scope on. We have the monitor on. Okay. And I'm going to start with decoding. We'll start at the beginning, right? Address decoders. We know that we can get to the ROM good, so I'm not worried about that. Bank. What are these? 1F and 1J. 1F and 1J. That is bank 1. I would be interested to find out. I can look at the schematic and find out what the address range is for these two ROMs that it says is 10,000. I can figure out what the actual range is on those. Because right here there's a signal called bank 1 that activates those two guys. These two. These three are no problem. It's these two where it says they start at an address of 10,000, which is just not possible. You know, so unless there's something funny, unless there's some funny business going on that I don't know about. This thing cannot, the CPU cannot address that high. It's not a 16-bit CPU. So are they doing some weird mirroring or something? You know, possibly. I don't know. Here's ROM 012. 012 ROM. Yeah. Okay, I'm not gonna go down that rabbit hole right now of trying to. I'm looking at these signals right here, and ROM 1 activates 1L, which is this guy, 304, and it also activates this guy. So these two are activated by the same ROM decoding signal. It's just the address. It's the bank switch. There's a bank switching somehow. Okay. Anyway, let's do this. Let's get to this. Address decoders. I'm not worried about signals ROM 0, 1, and 2. SRAM. Let's do... You know what I'm going to have to do, guys? I'm going to have to move the camera because I need to get to the fluke. So let's do this. Let me move you over here. Move you over here. And I need to move this stuff out of the way. Move this stuff. Move the fluke. Use the force, fluke. There we go. We'll move you right there. Yeah. Back it up a little. That's as backed up as far as it'll go. Alright. Okay. Let's do a write at 0. I don't know. Let's do a write at 100. That's RAM, right? Write at 0. 55. Loop. Alright. SRAM should be pulsing, which is 5R pin 8 is the 5R pin 8. Well, that looks weird. Right off the get-go, I am grounded, right? Yeah. Okay. That is an LS32. Pin 9 looks really good. And that is, that's an address line. So that's a buffered address line right there. Buffered address 12. 10 comes off of a 139. So that's a signal from a 139. Which if we can trigger that, we can slow it down. Okay. I mean, I don't love that, to be honest, you know. And to get a better look at these signals, I mean, this scope is decent. But really, if I want to get a really good look at these signals, I need to use the other scope, to be honest. Okay. I mean, I don't know how great of a signal that is. 4R is a 139 right here. And it is... Pin 1 is a buffered address line. These are all address lines, so they all look great. These are the ROM signals, and this is the seven is ROM 2. Okay, yeah, and what it's doing is it's disabling. I bet you, let's just stop everything. Okay, stop. I bet you this line is flatlined. Yep. Atari always does this. One of their ROMs is always enabled until something else is enabled, and then it will unenable. So I'll do a read from, let's do I'm going to prompt up a write at 0. Okay, 22. Okay. Now watch, I'm going to repeat and this will go high. You'll see it blip. Yeah, I got to do a single shot. Now it'll blip. Repeat. See that? Whenever you do something else, this will disable. That's exactly how that works. So that's no problem. Now, if I probe on pin 4, this is the RAM. Now I'll do a single shot, and this should go low when I hit repeat. That's pin 4, right? Oh, no. Yeah. Yeah, pin 4 should go low when I write. It's really not. That's not registering as a low. I think this is the problem right here. I think this chip is the problem. Could be. So we can, let's just stop everything. I'm going to grab a 139 and jump over that. See what we get. See if this will force it to a low state that we can actually read. Right? This guy right here. Okay. And I'm going to probe on pin 4 and see, let's do a write at 0 and we'll go 55. And let's do a single shot and see if we repeat it. Yeah, we're not getting anything on that. Oops. Let's go ahead and lift up pin 4 and see what this looks like lifted. Yeah, it looks the same. I don't like that it should be an actual low signal, and I don't think it's the 139. Weirdness. It's connected to a 132. It's connected to, yeah. NR. What does NR stand for? Program memory. NR. I'm going to hook this guy up and take a look at these signals with this scope. It just gives you such a better picture of what's really going on. Okay, no. 1, 2, 3, 4. Yeah. I'm going to move you up so that you can get a view of the other scope. Okay. And we'll look at that same signal for our pin 4, right? And I am looping. Oh. Let's do this. You see that? I mean, that's a good signal. There's nothing wrong with that. And we can go stop. and write at 0, 22. Okay, I'm going to do a single and hit repeat. Okay, they don't work. Yeah. I wish yeah, it's not doing that. How do I get this thing to trigger on? Single. Level, slope, negative. This is something I've never messed with on here, so I don't know what I'm doing. Triggering on edge. Yeah, let's trigger edge. Level, 1.64 volts. I don't know. Let's try 0 volts. I don't know. Let's try 5 volts. I don't know. Slope negative. Count. Okay, never mind with that. You just have to do repetitive and loop it. And why is that not going low? Writing at 0. Huh. No, look at that now. That's that same signal. It looks totally different. Looks like it should. I'm just running the UUT right now. I'm running the board. Addresses. Yeah, it's not even trying to access ROM right now, it doesn't look like. It looks like all it's trying to do you can see this ROM's being activated and it's reading from this ROM and then it's trying to read from RAM, because I bet you this ROM right here, the one where it starts off low, that's where all of the testing stuff is, and the information, the CPU goes to this ROM first and then starts to execute code. And I think this pulse right here is where it's trying to read from RAM and it's not able to. But you see up here, this decoder, my RAM signal's fine. That's the RAM enable signal right there. So let's follow that. Let's go to 5R, which is this guy. And you got that signal with this signal, or that signal is this signal. And this could be our problem right here. SRAM is not being enabled. It's supposed to be low enable. And this is an OR gate. So that signal or this signal, this signal is high all the time. You know what we can do is we can hit stop and let's put our cover on this guy. We can analyze this guy with the little scope. So let's move you back over down to the little scope. Little scope. And let me get this all set up together and I'll be back.